ಹೆಲೋ ಸಬ್ಸ್ಕ್ರೈಬರ್ಸ್, ನನ್ನ ವಿಡಿಯೋನ ಲೈಕ್ ಮಾಡಿ, ವಿಡಿಯೋನ ಶೇರ್ ಮಾಡಿ, ವಿಡಿಯೋಗೆ ಕಾಮೆಂಟ್ ಮಾಡಿ, ಮತ್ತು ಬೆಲ್ ಐಕನ್ನ ಟನ್ ಅಂತ ಹೊಡಿಯೋದು ಮರಿಲೇಬೇಕು.
So today's topic is congestion control, desirable bandwidth and regulating sending rate wireless. So what is congestion? A state occurring in network layer when the message traffic is so heavy that it slows down network response time. Effects of congestion. A delay increase, performance decreases. If delay increase, retransmission occurs, making situation worse. Congestion control algorithms. Congestion control algorithm is a mechanism that controls the entry of data packets into the network, enabling a better use of a shared network infrastructure and avoiding congestive collapse. Congestive avoidance algorithm are implemented at TCP layer as a mechanism to avoid congestion collapse in a network. So there are two congestion control algorithms which are follows. So leaky bucket algorithm. Leaky bucket algorithm discovers its use in the context of network trafficking shaping or rate limiting. A leaky bucket executing and token bucket execution are predominantly used for traffic shaping algorithms. This algorithm is used to control the rate at which traffic is sent to the network and shape the burst traffic to a steady traffic stream. The advantages compared with the leaky bucket algorithm are the insufficient use of available network resource. The large area of network resource such as bandwidth is not being used effectively. Similarly, each network interface contains a leaky bucket and the following steps are involved in the leaky bucket algorithm. When host wants to send packet is thrown into the bucket. The bucket leaks at the constant rate, meaning the network interface transmits packet at a constant rate. Bursty traffic is converted into a uniform traffic by the leaky bucket. In practice, the bucket is a finite queue that outputs at a time finite rate. Token bucket algorithm. The leaky bucket algorithm has a rigid output design at an average rate independent of the bursty traffic. In some applications, when a large burst arrives, the output is allowed to send up. This calls for a more flexible algorithm, preferably one that never loses information. It is a control algorithm that indicates when traffic should be sent. This order comes based on the display of tokens in the bucket. The bucket contains token. Each token defines a packet of predetermined size. Wireless congestion control protocol. TCP's congestion control suffers from a chorus when applied to the multi-chip ad hoc environment. To overcome this problem, we purpose a rate-based wireless congestion control. There are two components in WCCP. One is the transport layer. It replaces the window adjusting algorithm of TCP with the rate of control algorithm to regulate the sending rate. It monitors and possibly modifies the feedback field in the TCP data packets when it passes the outgoing packets from the network layer to the MAC layer and the incoming packets in the reverse direction. In the rate-based congestion control, to calculate the ideal sending rate, the source is in their need to a timely and easily measured metric which should satisfy two requirements. First, as mentioned in previous discussion, since MAC contention is tightly coupled with congestion, a candidate of congestion signal should reflect the condition of MAC contention and collision. Second, in order to fully utilize the shared channel congestion control technique for wireless network page without causing server congestion and packet collision, the candidate should indicate the available bandwidth. So rate-based algorithm. So rate-based algorithm requires the following changes to TCP: ideal time detection and indication that RBP needs to be started, bandwidth estimation, calculation of the window that we expect in to send in RBP, and timing between segments in the window, a mechanism that clocks the segments sent in RBP. Conclusion. The proposed modification schemes to the standard TCP congestion control algorithm is better in their characteristics, algorithms, and assumptions were presented. A comparison of their assumption, bandwidth estimation, window size manipulation, slow start phase, retransmission phase, congestion avoidance phase, and performance evaluation methods is conducted. The need for an efficient method to optimally utilize available bandwidth is essential in the wireless links of combined wired and wireless networks. Future research is to evaluate these schemas against each other by comparing them in various network scenarios that such varying bit errors, number of connections, link capacity, and bandwidth. Thank you.